Good morning, everybody. Welcome to another cold, sunny, but exciting morning of Chem 1105 General Chemistry with your host, me, Dr. White. I guess today is a TGIFC. Thank God it's Friday chemistry. And I like this TGIF. All right, couple important things. First of all, after reviewing and editing the videos I posted yesterday, I realized I forgot to do something important. And that is, first of all, my eyes getting better every day. Thank God. Thank you. Not to bring religion into the classroom, but I forgot to mention the name of my eye surgeon, ophthalmologist. That's Dr. Cabin. And Dr. Cabin did a great job. And I'm glad I found him. And I'm glad he's did this eye. And a week from this Monday, Dr. Cabin will be doing this eye. And then I'll be back to normal, whatever that is. But luckily, important health problem I have will be gone. Again, the great eye surgeon I've been using is Dr. Cabin. By the way, that's a personal commercial from Dr. White, just to say thank you, Dr. Cabin. All right, next. I made a mistake. I was looking at my syllabus. I'm thinking, oh no, I had the dates for Thanksgiving from last year, not this year. So week 14 and 15 were wrong in my outline. Guess what? I've changed it. And let me find what I'm trying to find. Actually, I have it as a Word document. I thought I had it as a Word document. Hang in there. I apologize. I thought I had it on this machine. This was also sent out to you as an email this morning. It's the duo two-step validation. All right, sorry about the delay. If you look on their screen right now, does everybody see the revised tentative outline? Thumbs up, people. Thank you, Spencer. All right, the mistake I made was in week 14 and 15. I had Thanksgiving in week 15. No, it's week 14. And because of that, I have changed the date for test number 4. It's only a couple days earlier, but it will help. It helps me a lot too. Test number 4 will now be on December 3rd. You were sent an email and it's an announcement. And this you should see also on your screen. This is the announcement. You can't attach a file to announcements in Blackboard, but it was my mistake and I corrected it. Instead of doing a whole new syllabus, I just sent you the outline. Essentially, nothing's really changed other than the 2 dates were switched or weeks were switched. And that's that. Now I have something else to talk to you about. And let's go back to Blackboard. Actually, I don't have to. I will go back to Blackboard. That's not Blackboard. There's Blackboard. And let's open this up. And now, if you go to the assignment area of Blackboard, you will see optional extra credit project. This is a extra credit project. Ooh, what's that? Well, let's find out. Thumbs up, people. Does everybody see? Extra credit project. 10, yes. 10 points. Thank you, Taylor. All right, let's talk about the extra credit project because this project is 10, yes, 10, 5 and 5, 10 extra credit points. If you do it and get them right, it's like adding 10 points to any one of your tests or your total, however you want to think about it. It's 10, yes, 10 points. I had to sneak that in one more time. What's this extra credit project? The extra credit project is to create a list of ionic and covalent molecules that you find, and this is important, in the ingredients list of products that you can be purchased, i.e., which is short for that is things that you can use in your daily life. You must find 5 different molecules that contain ionic bonds. You can also have covalent bonds, and 5 different molecules, and this is important, that only contain covalent bonds. Also, you can only use 3 molecules for any one product. That means I'm making you look at more than one thing. And to get your 10 points, you must hand in, meaning upload, a printed table, meaning a PDF file now, or a Word document with the product name, the name of the molecule on the ingredient list, and is it ionic or covalent? Always be sure to put your name on the table. You get 1 point for each correct entry with a total of 10 possible points, meaning you got to do 10 entries. I had about a year ago a student complain, how come you only gave me 8 points? These are all right. Well, you have to put 10 items. You only had 8, 1 point per item. Now, to make it interesting, you cannot use gasoline, water, sodium bicarbonate, carbon dioxide, ethanol, also known as ethyl alcohol, sugar, sodium chloride, oxygen gas, or nitrogen gas. Everything else is fair game. Now, how would this look? Well, you'll have a table, and the first column is product, second column is the molecule name, and the third column is bond type. And I gave you some examples, which you can't use water, which is why I put it in the table. If you have Coke, Pepsi, or whatever pop, you'll see the first item on the ingredients list is water, and that's covalent. Now, if you picked up a can of Campbell's chicken noodle soup, which I don't buy anymore, I make my own, but anyways, one of the ingredients is sodium chloride, and that's ionic. But you can't use sodium chloride, but I can in an example. And each one of these would give you 1 point. Now, this is important. Ingredients must appear on an ingredients label, list or label on the product. You can't say, oh, I found out a banana has this chemical in it or this chemical. because I've never seen an ingredient list on a banana. Same thing, oh, this is in the air we breathe. Well, I've never seen uh, ingredient list floating around the air I'm breathing right now. And also I've made oxygen gas, O2, nitrogen gas, N2, you can't use. Now, this is an optional project. You don't have to do it or submit it. But if you do, you can get 10, yes, 10 points. Now, please upload this to the assignment area as a PDF file or MS Word file. Now, this is very important because I've had problems in the past with this. This is not a group project. You can't share answers with other people. That's called plagiarism. That's against the student conduct or ethics of COD and any other college in the United States, not the world. I will follow what's in my syllabus if I catch you cheating. Plagiarism is a type of cheating. Now, a couple of important things right here. And how do you find out if something's ionic or it's covalent? Well, you can use Google to, or any other search engine, but Dr. Whitelaw knows Google. I've been using it since it first came out, and I think 1996. Somebody called me up, a friend of mine in California, and said, look at this on the internet. I said, what is it? When I did, well, type a question in that box. Whoa. So use Google, or you can ask your instructor, me, to find out, if you don't know, if a molecule is ionic or covalent. So again, 10 points. It's due by December 7th. That's a Tuesday. There will be no late projects accepted. You can hand it in early, but anyways, you have to create a list of 5 ionic and 5 covalent molecules found in ingredient lists of products. You can only use 3 molecules from one product, which means you got to look at 4 different things. And to get the points, you have to have a printed table with the product name, the molecule name, and whether it's ionic or covalent. And this is my sneaky way of making you think about, oh, these things I use in my daily life and things I buy, they're molecules and they have chemical bonds that are either ionic or covalent. Now, listen carefully. One, what's a good way to know if it's got an ionic bond? If it has in the name an alkali metal or an alkaline earth metal or most other metals, it's going to have an ionic bond. Sodium hydroxide is ionic. Sodium tallowate, which I'll talk about later on, is in bar soap. That has an ionic bond. And therefore, if you see an alkali metal or alkaline earth metal or other metals like iron or silver or things like that, silver nitrate, that's ionic too, but I don't think it's anything you buy. Now, let me show you how easy it is to get an easy point or 2 or 3. It's winter, by the way, I don't get any product placement kickback. I wonder, anybody know I can get product placement kickback like from this company? But for years, I've been using this in the winter when you get chapped lips, when it's super cold out. And it's going to be super cold out. It's winter coming. And if you look at the ingredients list right here, which you probably can't read, one of the compounds is phenol. And there's no metal name in there. And phenol, PHENOL, is a covalent molecule. And therefore, you put down Carmex. Are you writing this down? Phenol covalent. You all got 1 point if you want to use it. You just have to find 9 more. There are 2 more you can get from here too. So remember, 10. Oh, I got to put that down. 10 bonus points. Any questions? Oh, I almost forgot. As a special public service to you, my students, if you want to, either after lab or class, or you can email me before you hand it in, send me your list, I'll check it before you hand it in, and if there's something wrong, I'll let you know to change it. So there's no reason with a little effort on your time, you can't get 10 bonus points. By the way, blueberry time. If you go into your bathroom and look at your personal care items or toothpaste or mouthwash, or go downstairs to your kitchen, pick up some canned goods or open your refrigerator and look at some of the things in there, ketchup, mustard, other things, you should take you about 5 minutes to get 10 points. All right, any questions? All right, it's been a busy morning already. All right, let's go through the pH problem set. Thumbs up, people. Everybody see when I get to the top. Acid and base, not pH problem, acid and base problems, practice problems on your screen right now. Thank you, Amber. All right, let's go through it. First, what is an acid per the Bronsted-Lowry theory of acids and bases? And an acid is a proton, or if you just want to write H+, which is a proton, donor. What is a base per the Bronsted-Lowry acid-base theory? Proton acceptor, H+ acceptor. All right, 1 point each. Is the following an acid, base, or salt? And you should know this. Oh, by the way, not always, but most, if it begins with an H, it's going to be an acid. Begins with a metal, not always, but most of the time, it's going to be a base. So A, hydrochloric acid, acid. B, sodium hydroxide base. I also said salt. I threw in a little surprise for you. Oh, please pass the NaCl, NaCl, that's the salt. And the rest are acid, base, and acid. And you should know how to do that. Now, if the solution has hydronium ion concentration of 1.0 times 10 to the minus 3, what is the pH of that solution? And is it acidic, basic, and my spacing got messed up here, or neutral? So we're trying to find pH. We're given the hydronium ion concentration. In test number 4, important information, you will be given pH equal minus the log of H3O plus. Hold on 1 second, don't be lazy. Let me open up something. All right, thumbs up, people. Do you see important information on your screen? Thank you, Elena. All right, this is test number 4, important information, which is cleverly hidden in the lecture section of Blackboard. I would highly recommend you review this. And test number 4, I'll give you pH equal minus the log of H3O plus. And also remember, if hydronium ion concentration is 1.0 times 10 to the minus X, if you put it in there, then the pH is X. And I also give you Kw, which is I wish was named after me, but it's not. Ionization constant for water, hydronium times hydroxide, and this should be 1.0, which it will be on the test, times 10 to the minus 14. So let's go back to our problem. and we're trying to find pH. Now, pH equal minus the log of the hydronium ion concentration, which means if the hydronium ion concentration is 1.0 times 10 to the minus 3, what is X here? It's 3. Because remember, if it's 1.0 times 10 to the minus X, then the pH is X for this equation. Well, in this case, the pH is 3. Now it asks you, is this acidic, basic, or neutral? And if you look at the screen right now, it's probably one of the most important things I'll teach you this semester. Here's the pH scale. Goes from 0 to 14. In the middle at 7, that's neutral pH. Below 7, it's acidic. Above 7, it's basic. And I haven't been subtle in a long time. Can I go any bigger font? I could. You should know this. And it's probably one of the most important things I'll teach you this whole semester. So pH was 3, it's under 7. That means it's acidic. And I give you some more problems. I'd highly recommend you do these. Let's look at number 7, 8 points. Whoa, 8 points? Yep. And the question is, if a solution has a hydroxide OH minus concentration of 1.0 times 10 to the minus 3, what is the pH of the solution? And is it acidic, basic, or neutral? We're given this pH. We're given this hydroxide equal 1.0 times 10 to the minus 3. Now, in important information, it has pH equal minus the log of the hydronium ion concentration. Uh-oh, we don't have it. So what do? Well, we have to do 2 steps. Step number 1, you have to go from hydroxide to hydronium. How do you do that? Convert hydroxide concentration to hydronium. You use this. Hydronium times hydroxide equal 1.0 times 10 to the minus 14th. And in case you forgot that, I used to make students memorize that. But when I changed my philosophy on teaching chemistry, general chemistry, where I'm testing your ability to do it, not also your memory. If you look at the bottom of the page on your screen, H3O plus concentration in the brackets means moles per liter times hydroxide concentration equals 1.0 times 10 to the minus 14th. And therefore, now armed with that information, I can go back and say my first step, I have this equation. I want to calculate the hydronium ion concentration. So I have to get rid of the hydroxide OH minus. How do you do that when you multiply 2 numbers together to get rid of one of them? You divide by that. Anything divided by itself is the number 1. Therefore, if I divide one side by a hydroxide OH minus concentration, I have to do the other. And that cancels out. I'm left with the hydronium ion concentration equals 1.0 times 10 to the minus 14th divided by hydroxide. Put in the number for hydronium, do the calculation. I have hydronium equals 1.0 times 10 to the minus 11. Am I done? No, I'm trying to get the pH. So now I have to do step 2. which is use the hydronium ion concentration I just calculated and convert it to pH. How do you do that? Use pH equal minus the log of the hydronium concentration. And when I put in that number, which I just calculated, it's 1.0 times 10 to the minus x, where x is 11. And when you have 1.0 times 10 to the minus x, the pH is x. In this case, x is 11. Now we have to determine, is that acidic, basic, or neutral? And, oh, look, somebody left on the screen for us. That was a nice person. Awful Humor Friday. The pH scale, which you should know. The pH was 11. When the pH is greater than 7, it's basic. So that's the answer, basic. And I give you other problems, same thing, it's 2 steps. I highly recommend, hint, hint, wink, wink, say no more. That comes from Monty Python Flying Circus. You haven't seen Monty Python Flying Circus television show, some of the skits are on YouTube. You're missing a lot. Check it out. Probably one of the funniest things that's ever been on TV. All right, now let's move on. Let's look at number 10. What happens, and this is important, to the numerical value of the pH of a beaker of water at pH 7.0 if you add a few drops of concentrated NaOH solution? Well, the first thing you have to know is sodium hydroxide, NaOH is a base. Next, what happens? I'm not asking, does it become acidic or basic? I ask, what happens to the numerical value? You're at 7, the new number will be the same, increases or decreases, or smaller or larger. And we need to look at, oh, it's the wrong button to press. Here, we're at 7, we're adding a base, the pH will become closer to 14, it will increase. So for that question, because you're adding a base, the pH increases. Now B, a few drops of concentrated sulfuric acid. What happens to the numerical value of the pH of a beaker of water at 7.0? And here you have to know H2SO4, sulfuric acid, is an acid. And you also have to know this chart. And when you add an acid, the pH goes below 7 from 7. And that means the number, it becomes acidic, but that's not what I'm asking. The number, the numerical value will decrease. You add enough HCl or H2SO4, it'll go all the way down to 0. And that means the pH decreases. Now, let's look at number 11. What happens to the numerical value of pH of a beaker of a buffer solution? And notice I was nice enough to put an arrow in there and say, that's the key, buffer solution. If you add a few drops of a dilute acid solution, it should be solution, not solutions. But anyways, what's a buffer solution? You should know a buffer solution is a solution that resists change in its pH when you add a small amount of an acid or base. And when something's dilute, that's a small amount. So a few drops of a dilute acid solution, the pH stays the same. B, what happens to the numerical value of the pH of a beaker of a buffer solution? Say that 5 times quickly. Yeah, I did my own tongue twister. But anyways, it twisted my tongue. Let me get back to chemistry. pH of a beaker of buffer solution if you add a few drops of dilute base solution. Again, buffer solution resists change in pH, and the pH stays the same. So the number won't change or stays the same. Now you wonder, why do I have to know about buffer solutions? Well, they're used a lot in our daily life where your blood, I don't know if you, well, you can see it better here, my blood veins. You know, maybe the sand is better, yep. And the blood in there has a buffer. If your pH of your blood goes too high or too low, you're dead. And there's a great movie that uses that concept. The remake of it was, but the original one from the 1960s, Andromeda Strain, you should watch. It's an amazing movie. Scary, not horror, but scary, and just an amazing movie. That's the first one, not the remake. The remake, stinky. And that's a movie review from Dr. White. All right. Let's look at number 12, 10 points. If you have to add 1.35 times 10 to the third milliliters, ml, of a 1.5 capital M, that's molarity, NaOH base solution to neutralize 1.87 times 10 squared milliliters of an aqueous solution, what is the molarity of the HCl solution? As soon as you see neutralize, think of titration. And once again, if you look at important information, test number 4, you'll see at neutralization, moles of acid equal moles of base, which then can be converted for a monoprotic acid and base, which is all I'll ever give you on my test or final, excuse me. And that's milliliters of acid times molarity of acid equals milliliters of base times molarity of base. Again, this will be given to you. So at neutralization, moles of base equal moles of acid. Hopefully when you do the lab that we did on Tuesday, you'll see what it is to do an actual titration. Now, if we look at the problem, we're trying to find molarity, that's capital M, HCl. We're given the volume of sodium hydroxide and the molarity of sodium hydroxide to neutralize this amount of hydrochloric acid. So milliliters of base times molarity of base equal milliliters of acid times molarity of acid. Milliliters of base is this number, 1.53 capital M NaOH is the molarity of the base. The milliliters of acid is 1.87 times 10 squared, and we're trying to solve for the molarity of the hydrochloric acid, HCl. So what do? Well, how do we get rid of this number to get MHCl, molarity of HCl alone? You divide that by that number, because anything divided by itself becomes the number 1 and it's gone. Well, whatever you do to one side, you have to do to the other. And I did. So this would be molarity equals this number. I rewrote it this way. Molarity equals this base, milliliters, times this acid divided by this milliliters. And notice Dr. White's in his 3 significant figure, RUT 3, 3, 3. My answer is 3. And you should know how to do this. There are other practice problems I'd highly recommend you do. Anybody have any questions on molarity, acids, bases, titration? Interesting thing, I think I might have mentioned it. But if you look at either the hot dog or hamburger you eat, if you're not a vegetarian, if you use ketchup, not on hot dogs, it's Chicagoland, you don't do that, mustard, relish, the green stuff that glows in the dark that we use here in Chicagoland on your hot dog or hamburger too, mostly a hot dog. And if you use pickles, those are all items that are acidic. The pH is less than 7. Think about that. Next time you're with people or having hot dogs and hamburgers, they're putting ketchup on their French fries, you can tell them, the stuff you're using is acidic. The pH is below 7. People don't like wanting to hear chemistry when they're eating. No, don't. But it's true. All right. Any questions? Give me a chance to close some stuff here. All right, let's go back to my favorite topic, organic chemistry. Why? Because I'm an organic chemist. That's my true love in life, if you haven't figured that out yet. All right, we were talking about how to draw structures in organic chemistry, organic molecules. And the important thing to remember is there's always 4 bonds to carbon, always 4 bonds to carbon. Now, wrong color. Right color. By the way, and I'm not teaching this in this class, this is called pentane. It's a minor component in gasoline and other things it's used for. Now, the question is this structure correct? And the answer is no. Why? It's missing hydrogens. If we look at this first carbon, the line is considered in organic chemistry a chemical bond. And therefore, that carbon has only 1 bond. When you see a structure like this, you have to fill in the hydrogens. And how do you do that? Use high-level math. Let's look at this carbon. How many hydrogens should it have? Well, it's supposed to have 4 bonds. It only has 1. 4 minus 1 is 3. So I can put in 3 hydrogens. If we look at this carbon, how many bonds does it have? 1, 2. 4 minus 2. Remember, carbon should always have 4 bonds to it. That's 2. So I'm going to put in 2 hydrogens. Same for this one. Same for this one. Now, this last one, how many bonds does it have? 1, but it should have 4. So 4 minus 1 is 3. And that's how you do it. Now, one of the exciting things, and it is exciting, carbon can bond carbon atoms in chain like this. And we call that a chain because the carbons are linked together like a chain. But you can also have branches. If you look at a tree, you have a main trunk and the branches come out. Well, carbon atoms can do the same. And the question is, I got ahead of myself, so used to draw And the question is, draw in the hydrogen atoms for the following. So let's do it. How many bonds this carbon? 1. There should be 4 bonds to carbon, always. If you find an example where it doesn't have 4 bonds to carbon, let me know and we'll be rich beyond my wildest dreams. That goes beyond having my own Ferrari, Lamborghini, old islands in the South Pacific, a couple of fighter jets to play around in. Goes beyond that because it doesn't exist. All right, if we look at this carbon right here, it has 1 bond. 4 minus 1 is 3. So I'll put in that. Now let's get to something interesting. Let's look at this carbon. How many bonds to carbon does it have? 1, 2, 3. But it should have 4. So what do? I pop in a hydrogen. This carbon right here has 1 bond. 4 minus 1 is 3. This carbon here has 2 bonds. 4 minus 2 is 2. Isn't the math tough in organic chemistry? And the last carbon has 1 bond, but it should have 4 bonds. So 4 minus 1 is 3, and I'll put in my 3 hydrogens. And this is how you would draw this molecule. You know something? I've got to share the fun. Your turn. Why don't you practice drawing in the hydrogens for that molecule? See, Dr. White's a really nice person. He lets you have fun too. Remember, there's always 4 bonds to carbon. All right, I think everybody's done. If not, say I'm not done yet. I guess everybody's done. Let's look at this first bond, carbon. How many bonds do we see right here? 1. How many bonds should carbon have? 4. So 4 minus 1 equals 3. That means it has 3 hydrogens. Let's look at this carbon. How many bonds does it have? Let me clean up these little dots. 1, 2 bonds to that carbon, but carbon should always have 4 bonds, and therefore 4 minus 2, hard math, is 2. So I have to put in 2 hydrogens. And finally, the last carbon has 1 bond, but there should be 4 bonds to carbon. 4, yes, 4, and 4 minus 1 is 3. And that's how you write this molecule, CH3, CH2, CH3. Now this molecule has a name. Propane. And propane is the chemical, you don't think of it as a chemical, in the white tanks that you purchase or you can exchange for your barbecue if you have a propane barbecue like a Weber or others. And that's what you're burning to make the heat to cook the food that you then can enjoy. Dr. White loves barbecue. Especially steaks. No, I'm not a vegetarian, even though a good part of my diet in the last year or so is vegetarian, but I still like a good steak every once in a while. All right. Oh, this was fun. Let's do another one. Here's one for you to have some more fun. Again, 3 points each. Draw in the hydrogen atoms for C. 3 points. Your turn. Remember, there's 4, yes, 4, but you know I'm ambidextrous. I am. 4 bonds to carbon. And don't forget, there aren't that many shopping days till Thanksgiving. Oh, by the way, you're on my home field now, organic chemistry. General chemistry is important, but organic chemistry is the best. But I'm biased, I'm an organic chemist. All right, it looks like everybody's done, so I better get to work. If we look at this carbon, there's 1 bond to it. There should be 4 bonds to carbon. And therefore, 4 minus 1 is 3. So I'll put in 3 hydrogens. Same thing here. Same thing here. Same thing here. Sound like a broken record. Same thing here. I've heard a broken record. Have you? Same thing there. They each have 1 bond before I put in the hydrogens. Now, let's look at this carbon. There's 2 bonds to that. There should be 4. So 4 minus 2 is this. Now, let's look at this carbon. There are 3 bonds to it. 1, 2, 3. There should be 4 bonds to carbon. 4 minus 3 equals 1. So this has a hydrogen, and this is the same thing. 1, 2, 3, 4 minus 3, 3 hydrogens. And finally, this last carbon here, notice I have 1, 2, 3, 4 bonds, so it doesn't have a hydrogen. And that's how you do it. And if I look at the clock, oh no, we're out of time. Time flies when you're having fun with acids and bases and organic chemistry, especially organic chemistry. And once again, I should thank Dr. Cabin. I can see out of the side pretty good. And with that, I'm going to say have a wonderful weekend. Don't forget to do your practice problems. Test 4 is coming up. And don't forget, you can start working on the extra credit project. 10 bonus points if you hand it in. It's optional though. And with that, finally, gang gesund, be healthy. Bye now. I'll see you on Monday.